morning students, welcome in today's session. Now we have to start with a new topic, that is your arithmetic progressions. So in my today's lecture only I will be introducing you about the arithmetic progressions. I will give you the introduction of this topic so that you just can understand what we have to do in this topic and what is our syllabus which we have to cover during the discussion while we will be going through arithmetic progressions. First of all, this arithmetic progression, whenever you have to start with, you see, when we are doing number of activities in a day, we observed many things which follow a certain pattern. For example, observe any flower, maybe sunflower, or you can just see in your daily life grains or maize, spirals on a pine cone you can see there. So certain examples you can go through where what do we observe follows a certain pattern. You can talk about anyone's monthly salary. You can talk about the maturity of the amount of an investment of any fixed amount after fixed years of time or months, suppose after 3 years, 6 years, 9 years. You can speak about any pattern, or the best example to start with, if I will start writing the numbers. Don't you think that a pattern I am following? And what is that pattern here is? I am just writing the natural numbers. So if anywhere I will put a question mark here, everybody will raise the hand and will say, sir, next number immediately will be 5. What is that? That is your observation. You are observing that. Your observation is immediately, because these are the counting numbers. If I shift to 1, 4, 9 and then I put a question mark, now slower ones will take time to answer this question, because you have to take time to observe these kind of patterns in mathematics, especially I am saying. Like here you will see, now I shifted towards the square of the natural number. Square of 1 is 1, square of 2 is 4, square of 3 is 9. So immediately the next number will be the square of 4. And what is that equal to? 16. So answer will come 16. Means again, one's observation is there. This is a pattern somewhere which is following the square of natural numbers. So I need to know about the sequences before when we start this arithmetic progression. What is the sequence? After sequence you can speak about a series also. These two things you have to remember before starting the arithmetic progression. What is a sequence and what is a series? So if you write the definition of a sequence, what you can say? A collection of definite and distinct numbers. A collection of definite and distinct numbers. Definite and distinct numbers which is formed by arranging or arranged. You can write like this also. A collection of definite and distinct numbers formed and arranged according to some definite law or some definite pattern. That will be the best one, I think. According to some definite law examples I have given you here. You can see the examples I have written here. So, natural numbers. There is a pattern, you know. There is a law. After 1, 2 will be there. After 2, 3 will be there. Then if I am following the pattern of square of the natural number, that is the law. Write down a sequence with the square of natural numbers. 1, 4, 9. So I am following a pattern. I am following a law there. So these all numbers, whatever you have written here in this sequence, are called the terms of this sequence. This is the first term, this is the second term, this is the third term. So whatever the term is missing, immediately I can answer. Or if it will be asked to find the 10th term, so immediately I will say that will be equal to 10. So if here it will be asked to find the 10th term, so I have to see 1 is there, 2 is there, 3, so 10 square will be equal to what? 100. So immediately I can write that. So means if I speak from the definitions point of view of a sequence, I can say it is a collection of definite and distinct numbers. Definite and distinct numbers. And distinct numbers formed and arranged according to some definite law or pattern. So that is called a sequence, and all the numbers whatever we have arranged or written there according to that law are called the terms of that sequence. So here in this we are using the number A. To A denotes the term here. A denotes the term. In NCERT, whatever the first term, you will be writing A1. A1 will denote the first term. Similarly, A2 will denote the second term, and so on. Last term you can write by N here. So this is the way how to write these terms. If anybody asks what is the third term, so A3 is equal to 9 here. A3 is equal to 3 here. So A1 in the fit of A here you have to write A1. So the term is denoted in arithmetic progression by this small letter A. Remember this please. So A1, A2, A3, A4 and so on. Like A1, A2, A3 and so on. But first of all I have to verify now. Just now I am speaking about the sequence. I am not speaking about the arithmetic progression. So these terms are denoted by the small letter A. So in arithmetic progression also the number of terms I will be writing. So in terms of A1, A2, A3, A4, so on up to the last term means that is AN if I am writing there. So A1, comma, A2, comma, A3 and so on up to AN like this. So on up to AN. So this is a sequence. This is a sequence, and A1, A2, A3 and so on AN are the terms of that sequence. So if I come to the word now series. So in series, if I am saying this is series, as I said before starting this AP, we will make it very clear what is the sequence and what is the series. If the terms of the sequence are connected, if the terms of the sequence, any sequence as I have written there, A1, A2, A3. So if these terms of the sequence are connected together by a sign of addition, are connected together by a sign of addition, that is plus, is called a series. Is called a series. In higher classes, you will be finding a course there, sequence and series. So very interesting. So I am making it very clear. What is a sequence and what is a series? So if you are separating by putting a comma, then it is a sequence. If you are going to combine these like A1 plus A2 plus A3 plus so on up to AN, then this is a series. This is a series. Again here, this is the first term, this is the second term of this series. This is the first term of the sequence, this is the first term of the series. So please make a note of that. Sequence and series. What is the difference between the two? Now let us come to this arithmetic progression. No doubt arithmetic progression can be expressed in terms of sequence and in terms of series also. So how to study this? Now this is very clearly I have to follow a certain pattern to write the terms there in a sequence or in a series so that I can call that a arithmetic progression. So in an AP, like suppose I have written 1, 2, 3, 4. Do you think is an AP? I have written 1, 4, 9, 16 and so on is an AP. I have written here like 2, 5, then 8, then 11 and so on. I have written under root 2, under root 3, under root 4 and so on is an AP. I have written under root 2, 2 under root 2, 3 under root 2 is an AP or not. So these are some sequences I am writing, and out of those sequences if I want to identify which is the arithmetic progression. So no doubt you have to make it very clear, it will be expressed in terms of sequence or series where these are the terms. So very simple, if second term that is A2 minus first term, second term minus first term that is A1 is equal to your third term minus second term that is A3 minus A2. Anywhere if you are finding A2 minus A1 is equal to A3 minus A2, that sequence within the first three you will be able to identify is an arithmetic progression. You see here A2 minus A1, 2 minus 1 is equal to what? 1. A3 minus A2, 3 minus 2 is equal to what? Again 1. So answer is yes. This is an arithmetic progression. Come here. 4 minus 1 is 3, 9 minus 4 is 5. No. A2 minus A1 is 3, but A3 minus A2 is 5. So A2 minus A1 is not equal to A3 minus A2. So the difference between these terms is not same. So this is not an arithmetic progression. See here, 5 minus 2, 3, 8 minus 5, 3. Answer is yes. Under root 3 minus under root 2 does not mean is equal to under root 1. Please remember, most of the students they are writing the answer for such sequences is yes. It is not like this, dear students. You remember, only and only the like surds can be added or subtracted. These are not the like surds here. And under root 4 is itself a perfect square that you know is equal to 2. So answer is no, because second minus first is not equal to third minus second. Here again you see these are the like surds. Under root 2 and 2 under root 2 are the like surds. So when I will subtract this, I will be getting under root 2. Again when I will subtract this, I will be getting under root 2. So answer will be yes. So first of all, you make it clearly how to identify that whether the given sequence is an arithmetic progression or not. So this is there I have explained to you the difference of the second and first if you are getting is equal to difference of the third and the second, that sequence is always an arithmetic progression. So these are called the terms. So please be clear with this. Terms are denoted by A, A1, A2, A3 and so on. The difference is denoted by D. And so on. If you are moving to the last term, this is called the nth term. Please make a note what I want to make clear in today's lecture to you. You are simply concerned with two things in your syllabus. Nth term of an AP, nth term of an AP, and sum of n terms of an AP. These are the two things. So an, I am coming to the first part, nth term of an AP is denoted by an, and that is always equal to a plus n minus 1 into d. This is the one formula we have to work out. in our syllabus for this. And if you are talking from the sum of n terms point of view, Sn is equal to n by 2 into 2a plus n minus 1 into d. Remember, where a is always the first term, n is the number of terms, and d is the common difference. D is the common difference. Make a note of this. So everywhere we are concerned with a, n and d. A, n and d. So our focus will be there upon a, n and d. So please make it very clearly what is a. A is always the first term, and n is the number of terms, total number of terms in that, and d is the common difference. An is denoting the last term. An is the last term. Last term. And Sn means the sum of all terms. Sum of n terms. Sum of n. That is whatever the number of terms are there. Sum of n terms. So this all we have to use throughout the topic. So we are concerned with what is a, what is n, and what is d. So in all the questions I will take you back to what is a, what is n, what is d. So today within your first exercise, please try to identify what is a, what is n, what is d, and whether the given sequence is an arithmetic progression or not. Please do practice of this, because the basic skills I explained to you. If the difference of the second and first is equal to difference of the third and second, then definitely the given sequence is arithmetic progression. So I will continue with the remaining instructions in coming days. Till then, bye bye. Be in touch with this. Try whatever the instructions are given to you in your exercise problems. Thank you and have a nice time.